In this lesson, we're going to look at the neutralisation reaction of an acid by an alkali. First of all, we're going to look at the general equation. But before we do that, let's take a specific example. We're going to look at the reaction between hydrochloric acid and sodium hydroxide. Now we remember that acids in solution produce hydrogen ions, and we're going to represent these hydrogen ions using these red dots. Now in this beaker, the alkali, sodium hydroxide, produces hydroxide ions, which we'll represent with these purple dots. Okay, so we've got 5 hydrogen ions and 5 hydroxide ions, so we have equal concentrations of ions in each beaker. Now, not only does the hydrochloric acid produce hydrogen ions, but it will also produce chlorine ions. So we have hydrogen ions, those are the H plus ions, and we have chlorine ions, those are the Cl minus ions. We'll represent those with yellow dots. Now the sodium hydroxide doesn't just produce hydroxide ions, but it also produces sodium ions. So we can write that. The sodium ions have a plus charge and the hydroxide ions OH minus. Let's represent the sodium ions with a grey dot. Now let's look to see what happens when we add the hydrochloric acid to the sodium hydroxide. First of all, the hydroxide ions will join on with the hydrogen ions, like that, and they will cancel each other out. So the H plus ions join together with the hydroxide ions, the OH minus ions. The plus and the minus cancel each other out, and we're left with HOH, which is H2, there are 2 hydrogens, H2O, in other words, water. So we will have a solution of water containing chlorine ions and sodium ions. In other words, we'll have a neutral solution of salt. Now we can write the general word and symbol equations for this reaction. Whenever we want to write down a reaction in chemistry, it's always very important to know the general equation first. You have to understand the chemistry and know what's happening in the reaction. So in this case we can say that whenever an acid reacts with an alkali, we will always produce a salt plus water. Now in this particular case, now we're looking at a specific example. In this case we're using hydrochloric acid and it's reacting with sodium hydroxide, and as we saw in the previous diagram, the sodium will combine with the chlorine in the hydrochloric acid to form a particular salt called sodium chloride, which is also known as table salt or generically as salt. Now I'd just like to point out here in the general reaction equation that when we talk about a salt, we mean a generic family of salt of which there are many different types. When we talk about salt without the article, then we're referring to the stuff that you put on your dinner. So I just want to distinguish between that. There's a difference between salt and a salt. So a salt is the whole family of salts. So this could be any salt here. Now in this particular case we're forming sodium chloride and water. And the next thing you need to do is to go from the word equation to the symbol equation. Okay, so we've got HCl plus sodium hydroxide. They react to produce sodium chloride and water. Now we normally write a little symbol AQ. That means aqueous solution. So it's hydrogen chloride gas dissolved in water. And the same here. Really we're referring to crystals of caustic soda, sodium hydroxide crystals, that have dissolved in water to form a solution. And as we've just seen in the previous example, the sodium chloride now that is formed is in solution. We have an aqueous solution of sodium chloride. In other words, it's dissolved in the water. So if we take this aqueous solution of sodium chloride, we have sodium ions and chlorine ions, and these chlorine ions are now dissolved in the solution. In other words, they're moving around in between the gaps between the water molecules in this solution. Okay, so what's going to happen when we heat the solution? Well, the water will start to evaporate. Okay, all of the water molecules will evaporate, and as they do so, these sodium and chlorine ions will join up again to form salt, or a residue of crystalline salt at the bottom of the beaker. So we've actually been able to obtain a sample of sodium chloride by neutralising hydrochloric acid with sodium hydroxide. Okay, and this is actually a standard technique for the preparation of many different types of salt. You can choose a particular acid and a particular alkali to provide you with a particular type of salt, but that's for a later lesson.